Hey everyone, this is for the students who missed out on Tuesday, 14th of October on antidifferentiation. I'm going to try to quickly go through this concept very quickly, give you a lot of examples so you know how to do the problems. Given that this acts on Tuesday again, we have very limited time, but remember tomorrow you can always ask me questions as well. Alright, so let's have a look. F of x equals to a times x to the power of n. So very similar to your power rule, antidifferentiation only applies, and this method only applies when you have x to the power of something and a being a constant value. Okay. The rule says, okay, and this is the rule. Normally in class I'd explain why this is the rule, but think of it as the opposite of power rule. So instead of, let's say, power rule, normally you'd minus 1. Well, you're adding 1 this time. Instead of multiplying it by the power in power rule, then what you do is now you're dividing it. So dividing is the opposite of times, adding is the opposite of subtraction. Okay, so I'm dividing it by n plus 1. Now the answer, you always got to remember that you have to put a plus c, which I'll explain in a moment, okay? Well, let's do a few examples right now, just so you get a feel of how to anti-differentiate. For those who weren't here on Tuesday and haven't revised yet, okay? So let's say I give you a problem where I say f of x equals to, let's say, 5x, okay? So I want to antidiff now. This is the symbol for antidiff, which is really sigma, which you don't really need to know. You just need to know it's a curvy bracket right now, okay? Later on in year 12 it's explained. But anyway, so sigma of, I want to antidiff 5x. Don't forget the dx, you must have these symbols, otherwise it doesn't make sense. And again, in year 12, all these symbols make sense, or notations, okay? So this is my notation, antidiff of 5x dx. What is this equal to? Well, this is equal to, according to the rule, a, which in this case is 5x. Now the power currently is 1, so I'm going to add 1. Divided by, which now I've actually got the power plus the 1, so it's just n, which is 1, plus 1. Don't forget the plus c. You must have the plus c when you antidiff it. Okay? This now gives you equals to 5x to the power of 2 over 2 plus c. And voila, you've done the first problem. So antidifferentiation of 5x is 5x squared on 2. Now, if you're wondering what does this tell me, c is a constant, okay? C is a number that I don't know, but it doesn't matter what it is, because if I gave you a different equation, I said g of x equals to 5x squared on 2 plus, let's make it up, let's say 10. If I asked you to find the derivative of this right now, okay, you would actually do your power rule where you'd say, alright, well, g dash of x is equal to, and using the power rule, bring the power down, and it's 2 times a, which in this case is 5 over 2, x to the power of 2 minus 1. Plus, and well, you know derivative of 10 is going to be 0, okay? And this now gives you, and you notice 2 times 5 on 2, which is like saying 2 times 2.5, is actually equal to 5x, and then 2 minus 1, which is 1, and plus 0. And conveniently, this is actually the problem that I just gave you up here. So notice what you've done here is, this is your original function, right here, that's your original function. The derivative, okay, gives you this, the derivative. Okay, so dy dx gives you that. And then antidiff, which is in green, gives you the function. So you see how you're going from original to derivative, and then from derivative back to original. Okay, so it's really just a circle. So going forward is dy dx, going backwards is antidiff. Okay, so you've got f of x, and we normally, whoops, sorry, let me just fix that. we also normally write your function, the original function, after the antidiff as capital f of x. The derivative is known as the f of x. That's how we tell the difference. So after antidiffing, this function right here, this we write as capital F of x is equal to 5x squared on 2 plus c. This just basically means original function. Okay? That's pretty much it. That's the concept of antidiffing. But I'm going to do a few more examples just so you get used to this, okay? So let's do a few more. So let's say I give you now, let's say f of x is equal to 2, okay? Let's do that. In this case here, I'm still saying okay, I want to find an original function. So derivative of something will give me 2. That's what I'm saying. I want to know what that something is, okay? Derivative of what function will give me 2. So we're going to use anti-differentiation. Let's say anti-differentiate 2 dx. Notice my notation. Follow the notation. Don't skip any steps there, okay? Same thing again. We know that 2, even though it's a constant, there's no x, really it's the same thing as writing x to the power 0, because x to the power 0 is 1. So 2 times 1 is 2, okay? So let's write this out a bit more appropriately. So this is now the same thing as saying antidiff according to the rule, same thing, a, which is 2, x to the power of 0 plus 1, not minus 1 anymore because you're antidiffing, and then over 0 plus 1. Let's see. So this gives me an answer of 2x over 1 plus c, and this just gives me f of x, capital F, is equal to 2x plus c. Okay, this is my answer. This is the answer for an antiderivative of 2. Okay, because again, if you try, it doesn't matter what c is. You know, c represents a constant, whether c is 10, negative 1, or 2. If you find the derivative of this, it's going to equal to 2. Hence the antiderivative. So this is the original function. This is the original function. This is the derivative function. Okay? So that's what the goal is. Now let's do another example. Let's say I have multiple terms. Okay, multiple terms. Let's do another example. Let's say I say that we have f of x equals to, let's say, 2x squared. Actually, I'll make it 3x squared. Let's say 3x squared minus 5x. Okay? I want to find the antidiff of this. So I want to know the original function that if I found the derivative, I'll be able to find out the derivative of 3x squared minus 5x. Okay? So let's see. The derivative of antiderivative of 3x squared, so I'm going to write it out, antiderivative of 3x squared minus 5x dx. Okay? This is the same thing as writing, and you can do it individually. Just like power rule, you can differentiate individually, then in antiderivatives, you can also antidifferentiate individually. Okay, so what I'm saying is you can also do this. You can say antidiff of 3x squared dx minus antidiff of 5x. Actually, that might confuse you. I'm going to do this. I'm going to say plus the antiderivative of negative 5x dx. Okay? So you can do that. You can split it up. You can split it up individually and solve them individually. So let's use the rule again. So again, the constant is currently 3. It's x to the power of 2 plus 1 divided by 2 plus 1 plus, okay, same thing again. Antiderivative of this is, again, constant is negative 5, x to the power of, and this is currently 1, so plus 1 divided by 1 plus 1, and don't forget the plus c. Remember, c is just a constant. We just don't know when that c is for now. Okay, so that's why you always have to put the plus c. So this now gives me an answer of, okay, so you got 3x cubed over 3 plus negative 5x squared over 2 plus c. Okay, plus c. Conveniently, 3's cancel out, and that gives me an answer of x cubed minus 5x squared on 2 plus c. And remember, this is your original function. So if I ask you to find the derivative of this function right now, okay, the derivative of this function, you'll find that the derivative will end up being something like this, 3x squared minus 5x. Okay? That's how you do the antiderivative. The next part of the explanation that I want to talk about is, so now you know how to antidiff. But what is antidifferentiation? Okay? I'm going to give you in the easiest way possible to explain. I'm not going to go into too much detail. All you need to understand so far at the year 11 level is antidifferentiating. Antidifferentiating. Alright, antidifferentiating just simply tells you the area under the curve. Okay, or the function of the area under the curve. What do I mean by that? Well, let's say if I said antidiff x squared. Okay, if I said antiderive x squared dx. This just simply means if this is my graph and this is x squared, okay, I'm just looking for the area under the curve like that. Okay, and it goes on to infinity in both directions. So when you're actually antidifferentiating, so each one of these functions that you've antidifferentiated, okay, so each one of these, 1, 2, and 3, these are just functions to find out your area. They're just area functions. Now, a lot of the times you don't understand what functions mean. Think of it as a rule. It's a rule to find out the area at a particular point. Very similar to your gradient. Remember when I said when you're differentiating, you can find out the gradient function? Okay? That doesn't tell you the gradient. It just tells you the all the possible gradients. If you want to find the gradient, you need a point on the curve. True? Yeah? Let's say if I gave you f of x equals to x squared, and I say find the derivative, which is f dash of x, you tell me it's 2x. But that doesn't tell me the gradient. That just tells me a function for the gradient. When you want to find the gradient, I might say find the gradient at x equals to 5. Okay, so I want you to find the gradient at x equals to 5. So on this curve, I found this parabola. I want to know at x equals to 5, what is the gradient of my tangent? Okay, at that point, I want to know the gradient for the tangent. So then you'd say, all right, well then f dash at x equals 5 is equal to 2 times 5. So you can tell me the gradient is 10. You see the difference between function and gradient. Same thing with antidifferentiating. When you antidiff, this is just a function, not the area. It's a function. It's an area function. Okay, and then in the next video, I will show you how to find the area. Okay, right now it's just the area function. All right. So at this point, that's all I want you to understand from this video. Okay, in the next one, I'm going to tell you how to find out C, and then after you know how to find out C, I'm going to get you to find out the area. Okay, and that pretty much concludes Tuesdays and Thursdays session. All right, so have a look at that. That's your pretty much summary of what I need to teach. Yeah, all right, cool. And this is just exercise 23A and D. Okay, exercise 23A, D. Oops, sorry, I keep saying it wrong. A, B, not D. All right, cool.